Hi everyone, so my name is David. I work for a company called Axiomatics. This is not going to be a vendor pitch. I wear two hats. On the one hand, I work in the company I'm at, of course, where I pretend to work anyway. On the other, I'm involved in standards, and in particular, a standard that was killed many, many times over called XACML. I guess you've all heard about XACML by now, right? You were here on day one. It's not dead, not yet. So yeah, I'm going to walk you through the latest in terms of fine-grained authorization, and I'm going to show you some developer examples. I'll do a demo. Hopefully, the demo guys are going to be with me. So first off, authorization. The reason I spelled it that way is that at least British people are not going to complain about how I spelled it, or Canadians. Authorization tends to be very identity-centric. Every so often, I'll go to the Wikipedia page to check up on how they define it. And when I prepared for this presentation, I was happy to see that they actually mention policy. So the definition they have specifically is, authorization is the function of specifying access rights, privileges to resources. So far, so good. And then they continue and they say, in particular, I need glasses. More formally, to authorize is to define an access policy. And I think, I need to check the history, right? But I think it's the first time they mentioned the word policy. And usually within this community, within the IAM community, we talk about authorization in terms of you've authenticated and you're in, you're authorized. Actually, you all know that HTTP 401 is unauthorized, meaning that your authentication failed. Today here, authorization is going to be beyond that. A bit of a personal story. Axiomatics is actually a Swedish company. So when I first joined in 2010, 9 years ago, right out of high school, I was told that I needed to move to Sweden. And I'd never been to Sweden before, and all I knew is that it was kind of a quaint little country, kind of looks like the tree, you know, in the picture with snow and leaves, and you know, kind of like the PG-13 version of Game of Thrones, right? No one dies, except XACML, over and over again. And then I went to see this movie called Let the Right One In. Has anyone heard of the movie before? Yeah, a couple? There's a Swedish version of it. It's a Swedish movie, and there's an American version of it. I don't know what the American version is like. I'm guessing it's way softer than the Swedish version. Anyway, the movie is about a little girl. She's 12 years old, so you're thinking, oh, that's kind of a cute movie. It's going to go well, blah, blah, blah. Until you read the rest of the poster. She's been 12 for the last 200 years, so that's either a typo or really weird, and it gets worse. She just moved next door. And the whole movie is about making sure that she does not enter your apartment. So you really want to make sure that you want to let the right one in, and that's what authorization is about. It's about looking at the different attributes of the situation, the context, and figuring out whether you should let the person in. So if we stuck to, say, authentication protocols, and we knew that the person's name is Eli, that's not going to help us save ourselves from her. So I want to make sure today that through policy and through attributes, we're going to let the right individuals in and not the bad guys. She's actually a really nice person in the movie, by the way, but apart from the fact that she kills people. Yeah. Traditional ways of tackling authorization. I did a presentation with Jerry 2 days ago on authorization, and some of the things that we say is that typical techniques, RBAC, role-based access control, or authentication-derived authorization, they tend to be very identity-centric, because after all, what you know is who the user is, right? And you limit yourself to saying, okay, you've authenticated, you're in. Okay, I'm going to give you a role, you're in. I'm going to give you permissions attached to that role, boom, you're in. It's very much limiting yourself, and you rely on the applications to do the heavy lifting of implementing authorization checks within the app itself, within code, and then you lose visibility and you lose flexibility because you really trust that the developer is going to do a good job of actually doing authorization. When you do that, when you rely on role-based access control, when you rely on authentication, what you really do is that the users in your system, be it employees or external users, it doesn't matter. They're going to have birthrights, meaning that when you first instantiate the user within your user base, you're going to give them roles and permissions. And then as they evolve during their journey in the enterprise, or as they evolve as customers, you might actually forget to remove those roles and permissions. So these are birthrights. You have them at the very beginning. That's why you have governance tools like SailPoint, Savient, so on and so forth to actually do certification, recertification of your rights and make sure that you actually remove and add permissions as your role evolves during your lifetime at the company. Just to give you an example, Axiomatics has about 50 employees in total. I'm employee number 10. Like I said, I joined 10 years ago. I had a lot of rights back then. I still have those rights. Don't tell my boss. What we want to do, though, is we want to move to runtime authorization. In other words, instead of making decisions when the user is created or when we provision the user with permissions, we want to make decisions when the user or the client is actually trying to do something, right? There and then, you're going to look at contextual information and decide whether the user should be allowed to do what they're trying to do. So that's runtime authorization. Wow. There we go. Really bad clicker. I like to split authorization into 3 different types of authorization. There's functional authorization, meaning as a whole, can a user or a client do something? Can they print? Can they view documents? Can they send money? Can they browse medical records? Okay? We're not really asking about one particular item. We just want to know what they can do as a whole. This is really useful when you want to build in authorization inside of, say, a web portal, and you want to show or hide menu items, widgets, so on and so forth. It's also kind of like the softer side of authorization, meaning it's more about user experience, if you will, because you just want to show relevant things to the end users. And for that, doing stuff like OAuth and using scopes and roles and so on, it works relatively well. Doing it through policy, as I'm going to show you, works really well too. The second category of authorization is transactional authorization. By then, you know exactly what it is you want to do, what action, right? View, edit, delete, approve, send, so on and so forth. You know what you want to do it on. Is it a document and which document it is? Is it a bank account, so on and so forth? And we know who you are. So it's very specific authorization. The sort of authorization that works really well with APIs, and the sort of authorization for which you want to have policies. And the last type of authorization is data-centric authorization. And it's kind of a twist, if you will, on transactional authorization, except that instead of dealing with the one item, you're dealing with an unknown number of items, okay? Maybe 1 million or 1 billion, it doesn't really matter. So typically, whenever you're getting access to information within a database, and what you want to do is only get back those items that you have access to. You're not going to ask 1 million times, can I view item 1, 2, 3, 4, it wouldn't scale. So you have to think about a different way of handling authorization. And that's what I call data-centric authorization. Another thing that I've noticed has happened over the last couple of years in particular is that if you look at cloud platforms like Google or Amazon or Azure, so on and so forth, they all have their own version of handling authorization. So you've probably heard of Google IAM, Amazon, I think it's called IAM as well. They're actually building ABAC capabilities. They tend to focus on the container in the broad sense, not Docker container, but that as well, meaning that they're going to do security for S3, the bucket itself, not so much authorization for what's inside. So when you do authorization, you've got to think about both. Yep, you definitely have to do authorization for the container, for the box, if you will. But you also have to think about authorization for what's inside of that box, the data that's inside, the information, the transactions, the processes. This, by the way, is my neighbor's cat. And I was trying to shoot a video, and I was unpacking stuff, and the cat wouldn't let me take the stuff out of the box. So he was applying authorization to that box. Plus, I was told that if I put a cat in my presentation, it would be seen more times. So the secret to getting authorization right is a mixture of 2 different things. On the one hand, attributes of anything, attributes that describe the situation, the individuals, the resources, the action, the context, even things like device information, time of day, your location, so on and so forth. The second aspect, of course, is policies. Policies are kind of the secret sauce. They're going to bind those attributes together, and they're going to make sense of the attributes and then let you grant or deny access to resources based on those attributes. And actually, what I just said, grant or deny, is really important. Very often we think about granting access, but we don't necessarily think about restricting access. You want to be able to do both, okay? It's not just about opening up doors. You also want to shut them down. And that's what, brought together, that's what defines dynamic authorization or dynamic access control, which if you look up NIST, they call it attribute-based access control. I'm sure you've all heard the term. I mean, if you've heard XACML, you've heard ABAC. And speaking of which, if you look at the different standards that exist today in this space, you have XACML, okay? You have ALFA, you have Rego, and you could even, I didn't list those here, but the Amazon language for AWS and the Google language for Google, GCP, you could put those there. I didn't because, like I said, they kind of focus on the container, and they're also specific to that one platform, so they're not a standard per se, if you will. XACML has been around since 2001. It was created the same year that SAML was. It was definitely not as popular as SAML was. One of the reasons that authorization, fine-grained authorization, kind of sits in between the IAM side of the house and the application side of the house. So it's really hard to get people to agree on how to define authorization. It is a standard. The latest version came out in 2013, so version 3. A lot of people say it's slow. It's not. It all depends on your implementation, really, whether it's slow or not slow. Yes, originally it is XML based, but it is not XML. Okay, so if you hate XML, you don't have to hate XACML. I actually wrote the JSON version of XACML to make it easier for developers. ALFA is a newer version of XACML, if you will. It lives within the same family as XACML. It's within Oasis, and I'll show you what it looks like. It's a way that you can write your policies in a JSON-like notation, C#-like notation. And then Rego is a slightly newer initiative that tends to focus on infrastructure. It's the same architectural principles. You have a policy decision point. You have a policy enforcement point. So it's their own language. It looks a bit like Datalog or Prolog, if you're familiar with that, which gave me the shudders. But apart from that, it's an interesting initiative. Netflix uses it in their platform to make sure that not everyone is going to watch Let the Right One In, as an example. The main differences I want to call out is that in XACML and ALFA, you're capable of retrieving additional information, additional metadata from external sources. So if you wanted to figure out information about your users or your resources, you could just call out to a database, to an API to figure that information out through what's called a policy information point. You can't do that in Rego. So in my spare time, as I was preparing for this conference, I put together a bunch of scripts to sort of simplify how developers could write authorization and get going really quickly, spin up an authorization engine, a policy decision point, and deploy it. And I like to find cool acronyms, so I came up with Apollo because it's not rocket science, you know. Either way, it stands for Authorization Policy Lifecycle Lightweight Orchestrator. It took me a while to figure that out. And what I'm going to do in the demo in the remaining time is I'm going to show you how to define policies. I'm going to show you how to deploy the policies to a cloud-native policy decision point. And then I'll show you what it means to actually enforce authorization decisions, so what the integration looks like for an application developer. So first of all, the language I'll use is ALFA, the abbreviated language for authorization. ALFA defines policies. It defines attributes. It defines how you combine the attributes in those policies and how eventually you'll grant access or deny access based on those attributes. It mirrors what XACML had in its original model, but it simplifies it greatly. So let me just quickly jump to an example. This here is what an ALFA policy looks like. If I wanted to write one very quickly, I would simply do policy example and then define a combining algorithm, which is going to solve the conflicts for me. If there's a policy that says permit and a policy that says deny, the combining algorithm is going to be the one that says which one wins. And then here below I could say, oh, rule allow them in. Let me see. Yeah. Let's see. I was not expecting that question. Say what? Yeah, thanks. Let's do 20. So ALFA scales. And there you go. So you could easily say permit, and that's it. You've written a very simple policy. I mean, you might say it's really not that exciting. All the policy does is let me in. Yeah, great. But this is where you could start adding your attributes. So you could say something along the lines of target clause, and then maybe I want to look at my role, and then I want to say manager as an example. And if I want to say use age, say over 18, you could do that. You can see, or you might be able to see that apart from the fact that Eclipse is really slow, it's actually complaining that age does not exist. So I would have to go define my new attribute. The bottom line is you can choose what attributes you want to use. And of course, here I have to go figure how you determine values for those attributes. If you use age, then you have to have a system that is capable of giving you the age for that user. So this is what alpha looks like. There's an example in the slides that if you want to go back to that example. There's a bunch of examples on Wikipedia as well. I try to give back as much as I can to the community. In this particular example here, we're controlling access to documents. And what I'm doing is I'm defining, there's a hierarchy of policies. So the top one says, OK, we're dealing with documents. The one below that focuses on the action. You're trying to view documents. And the one within that focuses on your role. So here, managers can view documents. If you're a manager trying to view a document, then boom, access is permitted. The second thing you want to do is when you've written your policies, you actually want to deploy your policies, right? Writing policies, if you don't have an authorization engine to actually decide based on those policies, it's kind of pointless. So in my little example, as I got ready, I used Apache Ant. I know it's a really, really old utility, but that's what I grew up with. It works quite OK. You could do the same with, say, Maven or other deployment utilities that you could use. In terms of PDP, policy decision point, there's lots of implementations out there. Obviously, we have one at Axiomatics, but if you want to use a really good one, Auth'z Force is an open source initiative. AT&T did one that's slightly older. So there's a lot of choice out there. And then the last thing you want to do is actually, once you've spun up your PDP, you actually want to call out to the policy decision point and enforce that decision. So going back to my demo, OK, now that it's zoomed in, I'm kind of lost. But all right, let me remove this policy. And I'm going to bring in my lockdown policy, which, as you can tell from the name, locks everything. So this policy here says deny. Not only that, when you get denied, you're going to get a message saying why access was denied. OK. Now that I've done that, I'm going to go package my configuration. The configuration is passed through a YAML file, so typical sort of deployment model that you would have for cloud-native services. So let's let it compile. Now's a good time to go for coffee, by the way, because this is Eclipse after all. And then we're going to make sure that my PDP is dead. Yep, good. And I'm going to spin it up. So all it is a single jar. We call it a cloud-native PDP because you could just run it directly in, say, Beanstalk or Docker or whatever you want to run it in. You could scale it up, scale it down. By design, in Xactwell and Alpha, the authorization service is stateless. So you could have 1, you could have 10, you could have 100. It doesn't matter. Okay, that's actually really important because it means that you can scale your authorization. If suddenly you had 1 million or 10 million or 100 million authorization requests, you could still handle that load. Okay, so my PDP is now running. And I'm going to take Postman, and I'm going to send an authorization request. I'm going to say, can Alice, the manager, what is she trying to do? She's trying to view a record in record 123. Let's send that off. And I was going to say, if all goes well, but it was too fast. If all goes well, I get access denied. And you can actually see, I don't know if I can zoom in Postman, by the way. Sorry about that, but yeah. Here I'm getting access denied, and I'm getting a reason why access is denied. Okay, so that's kind of one of the nifty features of Alpha. Not only can you allow or deny access based on attributes, but on top of that, you can actually say why you're getting access denied or permitted. One more thing I forgot to mention on the slide here is that the language we use, the format we use to send an authorization request and to get a response back is the JSON REST profile of Xactwell. And all it is number 1, JSON, duh. Number 2, it's just key value pairs. If we go back to Postman and we look at it, you'll see that all it is I'm saying I have an attribute called object type, and the value is record. It couldn't be any simpler. It's really small. Very basic. It actually maps to the policy directly. So if I went to my policy and I looked at one of my policies here, I have an attribute called object type, and it's actually the same one as what was in the request. Okay. Now, if I wanted to deploy my real policy, the records policy, so again, I'm going to kill my authorization service. There we go. I'm going to regenerate my configuration. And I'm going to run it. And now if we go back to my Postman and I send an authorization request, I should get a access permitted. And there we go. And you see the response is really tiny. All it says is permit. Great. That's super simple for developers to enforce in the code. I mean, all you do is if permit, then boom, you can go. If deny, then you got to handle the flow. So it's really simple. And that in a nutshell is policy-driven authorization. We do have an SDK, open source SDK that I wrote. I can show you a quick example of what that looks like. Essentially here, you can see lines 37 through 42. I'm building my connection to the authorization service. And then 44 through 64, I'm building that authorization request, kind of like what I do in Postman, but this time through code, through Java. And then I just post it off, and I get a response back. If I click send, it's going to be relatively underwhelming. I get permit back. Very simple. And that wraps it up. Oh, no, sorry. One more thing. What we've realized over time, I'm not trying to quote Steve Jobs, by the way. What we realized over time is that one of the easiest integrations you could do is with API gateways and micro gateways. So in the traditional world of APIs, of course, it would be web services gateways, API gateways, the likes of Apigee, Kong, so on and so forth. And now that we have microservices, we're looking at things like potentially Istio or 42 Crunch, more lightweight gateways. And one last thing, actually, that I'd forgotten. Yesterday, Hans Zandbelt, who's the guy on the right-hand side in the picture, who happens to be Dutch, did a shout-out to Carlos Garcia, who the previous day had done a presentation on Kong and fine-grained authorization. So I figured I might do a shout-out to the shouter, so the shouters shouted at. Anyway, and if you know Droste, Droste is a Dutch cocoa brand, and they're famous for the design effects. So it's a picture in a picture, so on and so forth. And I think that is it this time. Thank you. Questions?
Actually, I do have one.
You asked the question about fine-grained authorization earlier, right?
Yeah. So you mentioned Hexacamal and ALFA, and I think Rigo was the other one you had up there. Do you have any thoughts on UMA?
No, I mean, UMA definitely has a part to play, right? And I'm not saying UMA is not good at all. No, it's different. That's all. UMA is about user-managed access. So the user gets to define who can do what on their data. So if you take a medical example, I, the patient, would say that this particular doctor can get access to my data, right? So it's consent management. Whereas in ZACWL or Alpha Rigo, what you would do is define policies about what can happen generally speaking. So generally speaking, a doctor can view the medical record of a patient they have a working relationship or doctor-patient relationship with. Or nurses can view medical records of patients in the same unit. That's what we do in ZACWL. You wouldn't be able to do that in UMA. Right. And I think the two can actually play really well together because UMA can be a source of information for us to make policy decisions on. So, yeah.
So with Alpha, we find everything that was possible before with Camel. So you demonstrated permit and refused, but we have also taking another action. Like to elevate maybe the level of authentication, or maybe to filter out the result that is unmatched.
Yeah, absolutely. And the obligation example I had in there, that's how you would convey these additional actions like trust elevation, two-factor authentication, or rerouting a user to a specific page. So yes, there's things that are possible in ZACWL, XML ZACWL, that are not possible in Alpha. For instance, XML ZACWL was they thought about like using XPath to be able to select stuff from XML payloads. We don't think it should be part of the policy, therefore it's not an alpha. We just kept what's really important. And I think there's even more work we need to do. We can go even further in terms of how much we simplify alpha. So, yeah.
All right, and we are out of time. So thank you, David. It was really good.
Thank you.